So thank you very much for having us. We're actually really excited to have this panel because all of us, we've known each other for quite a while, but we never had the chance to be on a panel together. So it'll be great to debate some ideas, talk about some great stuff about quantum. So I'm joined with a great panel. So myself, I'm Martin Laforest. I'm the managing partner at Quantacet, which is a fairly new VC fund focused entirely on quantum startups. So we're one of 5 in the world that has this specific target. We started about 3 months ago, and we made our first few investments, and then we keep on going. To my left, I have Marie-Ève Boulanger. She's a program manager at PINQ², which is roughly translated to the Platform for Innovation in Digital and Quantum of Quebec. It's a center for HPC and quantum where they help and support enterprise in their quantum journey. She can tell you a bit more about that. After that, we have Sarah Blanchette, who's the executive director of one of the very first undergraduate degree in quantum information science at the University of Sherbrooke. Then we have Julien Chosson, who leads the IBM Quebec partnership specifically for quantum. IBM is one of the leading company developing quantum hardware and software, creating communities. And they have also installed, I think it's their 5th quantum computer outside of their premises in Bromont, just 100 kilometers from here, and the only one in Canada so far. So we'll talk a bit more about that. And then we have Vincent Thomasset, who's the director of research and partnership at Productique, Quebec, which is loosely translated, a collegial center for technological transfer, and they focus on advanced manufacturing. So the goal today, we'll talk about quantum, the quantum industry. You've heard from our friend Ghislain Lefebvre this morning from Algo Lab, what they do. So we'll still spend a little bit of time explaining what quantum is and how you or your enterprise can benefit from quantum. But we'll focus a bit more on probably one of the greatest challenges that we are facing as a nation, but also as an industry, which is the workforce. I personally had the chance to be an early student of quantum, but now we need many of them. So we're already behind in terms of workforce, and the industry is really just starting. So just a quick recap. Quantum technology, it's multiple different technologies. You can have quantum computing, you can have quantum communication, quantum sensors, materials. So it's technology based on quantum mechanics, which is the behavior of atoms and molecules, where we're trying to leverage and control those effects to create technology. Today, we'll focus on quantum computing because this conference has a little slight towards the AI, so we'll decided to focus on the computing side, but also because it's probably the most transformative technology that will come out. So why don't we get started right away? So I'll ask Julien maybe to give us a layperson version of what is quantum computing good for, and then where are we today? Where are we going? Why do we care? Just give us a quick bite.
Okay. So I'll try to do that. Quantum computing, we believe, will have an impact in 3 domains specifically. The first one is in simulation. The nature is quantum in itself, so we better have quantum computers if we want to simulate nature and molecules. So that's one area. The other one is in machine learning. There is a whole field called quantum machine learning, where we believe we'll be able to break the various plateaus that classical machine learning might face with certain data sets and algorithms. And the last domain where quantum will make an impact is optimization. So there are complex optimization problems that we hope to get a better answer actually out of quantum computers rather than classical computers. So that's the 3 main domains where we aim to have an impact. And right now, the quantum computing technology is at a stage that we call we're in the quantum utility era, we call it, where quantum computing is delivering results that are really in competition with what classical can deliver. And they are in this stage where each one is helping the other make progress. And we have the hope for, of course, quantum to win this race, but though it will be only for certain classes of problems. And there's a statement we heard earlier that, for example, quantum computing can perform certain calculations in seconds, while classical computers would take a very long time. That can be true, but only for certain classes of problems. Classical computing is not going away, but many new problems will be able to find an answer thanks to quantum computing.
Okay. Thank you. So now if I listen to you, Julien, there's a lot of will do and might do and a lot of future stuff, right? So maybe I'll premise in saying that right now, quantum technologies is a real industry. And what I mean by a real industry is, I mean, there's VC people that invest in companies, there's startups, there's giants that are investing. I know I've been asking Julien how many IBM is investing. He refused to tell me. So we don't know, but significant amount of dollars. There are billion-dollar companies. There's been IPOs, mergers, some companies disappeared. So it's a real industry. It is young, but it's a real industry. So maybe let's stop talking about the future for a second and let's talk about the present. So Marie-Ève, you work very closely with enterprise, which today are trying to find out whether quantum computing is for them or not, or trying to figure out. So can you give us, maybe not like real example, because I'm sure there's confidential data there, but can you give us why a company should start looking today for a technology that might benefit them not today? So
yeah, I do like your question. So I'm a physicist by training. So I like always to say that, quantum computer exists, it's happening right now, but it's still a research tool. However, companies, and this is what we say to them when we talk to them, is that you don't want to miss the train when the real thing, the real machine that has all of those promises that Julien talks about will be there. So it's really by having this in mind that, so there's, as you said, it's a real industry, there's a technology shift that is happening and you don't want to miss the boat. And I'm sure we'll talk about this later after on, but it takes some time to get the training to be able to use this new technology. So it's a disruptive technology. It takes some time to getting used to it. Not because that it's particularly hard. It's just that you have to put your mind or your brain in a different mindset to address problems in a new perspective or in a new way. So as you said, yes, right now we do have companies, Quebec companies or international companies that are using quantum computers, such as the one that is in Bromont. However, it's not using it to have like those mind-blowing, cutting edge like results, but it's more in this training perspective. So once the big thing is there, they'll be ready.
Okay, so you mentioned that it's important to start getting ready early. So is it fair to say that if you just wait until there's a like a useful quantum computer around, are you telling us that we cannot just over the weekend just start using it?
I mean, you can try. No, it takes some time. And as I said, it's also a question of changing your mindset. And for companies, perhaps it involves, getting new people, hiring new people, training the people, the decision maker. So it's all of a shift of like, well, we have these problems. We know very well how to solve it with classical computers. Now we need to address this problem that we know about on a different approach. So it takes times, and anyone can start training right now, right away if they want to. So when the premises will be there, will arrive, because it will arrive, they will be ready.
Okay, so which give us, I guess, the perfect segue to start talking about the workforce. So I mentioned at the beginning, workforce is one of the big challenge that we have. We cannot hire fast enough, or we cannot train people fast enough. And here we're lucky to have Sarah Blanchette, who's leading one of the very few undergraduate degree in quantum. Just a few years ago, the people you'll see in quantum would be, master degree level, PhD degree level. But are we still at that point? Or I should make it even bluntly. So why did the University of Sherbrooke start an undergraduate program? And why is there's not more undergraduate program out there? So might be a tricky one there, but I'd like to hear you on that. So what are you doing in Sherbrooke? And do you think there's going to be more of that moving forward?
Yeah, so Sherbrooke has been teaching, quantum physics for 40 years now and developed expertise in that field specifically. And as just like talked this morning, we know that there's a skills gap and we need to train more people. And so we were thinking, well, not me, but colleagues at the time, can we make a new program which isn't, 10 years long? Because right now people do their bachelor's or master's or PhD and then however many postdocs they want to do until they switch from academia to industry. And so the idea was to have a specialized training program which would take people from CEGEP to industry in 3 years and a half, after the university. So a program which is 3 years and a half in university and it's professionalizing. So people would be ready to integrate the workforce right after their undergrad. And in science, there's like a mindset where you do a master's and a PhD. It's pretty uncommon for people to not study after their undergrad. So we built the program with all of the necessary tools for students to be able to work. So that was kind of the idea behind, having a shorter program to be able to feed out more talent in the field. So we decided to specialize on quantum software development. Other universities in Australia, for example, are teaching quantum engineering, but we're really the only program focused on quantum software worldwide. So I'll be able to tell you a bit more about how successful it is in a few years since it just launched last year. So students are in their second year.
Second cohort right now?
Yeah. And basically, so we were looking for students who like physics, math, and computer science, 3 pillars of quantum computing. So we have interesting profiles. And why other universities aren't building curriculums like that, there's a lot of papers around the literature talking about quantum education and how to best teach quantum. And it's a challenge. I mean, would you rather take someone who's been working in computer science for many years and retrain them, or have new talent specifically trained with quantum computing? So it's an open question. Some programs are just focusing to keep majors in physics and computer science and have some minors, so people are quantum aware but are not like quantum specialists. I think more and more we're going to see more programs, but I think people are it's still kind of risky. Quantum is still to be seen if it's going to happen as big as we predict it will be. So is it worth it to invest a lot of resources to build a new program? We thought it was worth it. Perhaps others are a bit more scared in that sense. I think that would be the main reason.
So you mentioned, right, you focus on quantum software development. There's other places that focus on hardware. I can claim here we need everyone. Why specifically did Sherbrooke choose software development?
I think the answer was that, the physics program at the university is very experimental. So most of the professors are working on experimental physics in the quantum computing field. And so I think there was a gap in software at the university, and we have more and more professors coming into algorithm research, but it's still a pretty small team. And right now, there's obviously needs in hardware and software in the industry, but software is going to be more and more prevalent. It's going to be very important. And also, these students, if ever quantum, doesn't show up, they can just transition to computer science or data analysis or AI without a problem. So I think that was part of the reasoning.
All right. Vincent, I'll turn to you. So often when we hear the word, quantum, first of all, our head goes in the cloud. And then we think, physicists, engineers, lab coats, big clunky labs, things doesn't work, duct tape, the whole thing. I went to visit Productique, Quebec. You guys are dealing with CNC machine, lathe, like you're doing advanced manufacturing. So one might not associate that with quantum, but here you are. So tell us, like, where advanced manufacturing people or more like technical hands-on people, where do they fit in this whole equation?
Yeah, that's a good one. But it's all about technology transfer and adoption. I mean, either it's automation, Industry 4.0, or quantum, they all face the same adoption challenges. I have to say, although quantum is disruptive, it will still rely on manufacturing technology to create, design, produce, and support this technology. And Productique Quebec involvement in the quantum zone was in two axes. The first one was to develop the expertise for prototyping and help people that are creating quantum technology to industrialize it. So we worked with a company. We helped them to redesign their mechanical parts for their sensor. And by doing so, we helped to save like a third of the cost for their prototype production. And we got rid of a lot of manufacturing tasks that needed to be really precise and a lot of assembly manipulation. By streamlining their design, they have a more robust product now. That's the first axis. And the second axis we work on is to help to bring enabling technologies in the region to be able to support quantum supply chain. So to do so, we need to bring the technology to build the knowledge about those technology and then have people trained on that. And not only at the university level, but we need to bring the vocational training and the education schools as well, and the college. So we need to have some kind of continuum throughout the training in order to have a real supply chain supported in the region. So we feel that if we bring the proper technology and the proper know-how, we will have something really special in Sherbrooke supporting quantum.
Okay. So continuum of education, bringing, you mentioned vocational technician. I think it's I'll go back to you, Julien. So IBM, you guys have a massive team of people working on your effort in quantum from, well, we don't know really, but yeah, PhD level, you have master, undergrad, technician. Like typically, like, would you say your team is, do you need to have a quantum background to join a quantum effort, or there's place for other things? Like, if I want to join in, like, do I need to go back to school, learn quantum mechanics? Or, you know, a bit like Vincent was mentioning, like, we need the skills anyway.
So it depends, is the answer. So if you want to do, for example, some quantum computing, usually, yes, we're going to look for, or even building a quantum computer, yes, we're going to look for, of course, the right skills. But quantum is creating tons of jobs that are going to support the technology that would require you to have some, of course, technology affinity, but would not require you to have, for example, deep knowledge in PINQ². And I'm actually a great example of that. When IBM hired me, the only thing I knew about quantum was how to spell it. I learned. They have an excellent training program, internal and external. Most of the content is actually free on the IBM Quantum platform. Anybody who has a pulse in the audience can actually start using a quantum computer before the end of the day. You won't do something utility with it by the end of the day, but you can start using it. Yeah, you don't need to have deep expertise to start showing interest and supporting the industry, whether you want to support it business-wise, on the legal side, on the finance side. Like, there are tons of aspects where quantum needs help to for the industry to really grow.
Well, actually, I think I'll take the opportunity and I'll push on that. So far, we've talked a lot about the technical aspect, and there is definitely a big technical part, right? Scientists, engineers. But for the people here in the room and online, if they're not from technical, if they are, you know, you mentioned legal, marketing, like, can they join the adventure, and how? And do we need them, or are we going to need them? Like, and this question is open to everyone, like for the non-tech people. Is there an opportunity now or soon? And what does it look like?
I think there is a strong opportunity now. I mean, the number of companies that are starting to explore and adopt quantum, whether large corporations or and you are very well aware of that, the startup landscape is growing extremely fast in the quantum world. Well, all these companies, you know, they need all this support system to be operating and growing. And so you can make an impact in quantum joining a quantum company tomorrow. Well, depends on the length of their recruitment process, but tomorrow virtually.
If I can just add, you know, I think the beauty of quantum computing is that it's very multidisciplinary. And so and you can learn everything, you know, like whether even if you're not in school, like obviously you learn when you work. And so just like, you know, in my old team, we had mathematicians and physicists and computer scientists, but nobody came in with a deep understanding of quantum computing. You know, we all learned on the job. And so I think for people with science backgrounds, it's like very realistic to join a company and to learn about quantum computing while you're working. And for people in HR or legal, like obviously there's a bunch of opportunities for companies in quantum who are looking for non-technical people, but who can contribute in a different way, but in a useful way in different quantum companies.
And perhaps, as you said at the beginning, so the field of quantum technologies is very, very broad. So you don't have to be a specific expert that's in quantum algorithm to be able to work in that field. And we do need the help of experienced people from different backgrounds to learn from the past mistakes. So take AI, for example. It's been like 20 years that now this is I keep saying it's a brand new thing, but you know, the technology is disruptive. It's happening at the moment, but we're still having some legal issues or ethical questions. Why don't we learn from that and say, okay, well, can we have people interested in those questions and want to transfer those skills to quantum? So we address those issues that might happen in the future, but right now. So when we are ready, then at least we'll have some answers.
And maybe jumping on Marie-Ève's point, like at the university, we have a professor of applied political science who is working on the ethics of quantum computing. So, you know, she's not at all technical, but she learned enough to be able to start asking the questions of, you know, what are the dangers of quantum computing, how we can address it for it to be integrated nicely in the society. And
well, maybe so we all touch that part a little bit is the idea of reskilling or upskilling. Okay, so we're missing people, so we cannot wait for people to graduate. We need people now. So let's say I'm a programmer or an electrical engineer, and then I'm online or I'm here in the room. I'm absolutely amazed by what we're talking about on stage, and I want to join. Like, how do I just go and try to pretend that I know quantum? Like, do I go knock and hope somebody believes in me? Like, what are the opportunities today to maybe upskill either on my own or is there a program? And maybe I'll put you on the spot, Vincent, because you're sort of in the middle of this right now, right? So you have a background that was nothing to do with quantum. You're manufacturing now. Your organization's slowly getting in, so you're learning as you go. So.
Yeah. Well, it's all about the enabling technologies. So we have to be aware of what technology needs to be developed and put in place to support all those quantum initiatives and the new technology that are going to be needed to develop sensors, to machine particular materials. And this all needs to be developed, de-risked, bring the knowledge, and then transfer that to the new people that will operate those machines. So it's all on the ground side, but it will support. And after that, all the maintenance of those equipment, we need to be able to operate the maintenance locally for those high-tech equipment as well. So we need those. I always forgot the formation continue.
Continuous learning.
To upskill people that have basic knowledge about those technology and bring them to know that particular technology that supports quantum.
So, Marie-Ève, I assume at PINQ that, you're helping enterprise in their quantum journey. So I presume that these enterprises have no prior quantum knowledge. So you're right in it. So how hard it is or how realistic it is for a programmer, an engineer, or somebody who doesn't have the quantum background to really get in, learn to a point where they can then be useful to a quantum company or another company looking into, like, how they can get the useful skills without having to do a 5-10 year degree.
Yeah, it's an excellent question. So one of the things I like doing when speaking with companies is say, well, are you interested within the academic partnership? Because as I said at the beginning, it's still a research tool, and academics, most of the talents are within the academia. So by having, a joint project, that can be something that is more stimulating. Because you need to, yes, you have to be interested. You say, okay, well, I want to start now. Fine, perfect, we're going to help you, but you need to have, I believe, a concrete idea of our project to at least keep moving into the right direction. So that can be, a great first step. Then in question of how long does it take, it depends of the how good you're at learning. Are you doing this full-time or part-time? Do you need to build a team internally? Will you dedicate a full-time, resource to this project and then hire some interns around this? So typically building a good project, it might take a year or two. And I would say at least minimum, 6 months training before, being able to think on your own about how to implement, quantum algorithms for them to be useful.
So what if I'm on my own? What if it has nothing to do with my current job, but I want to learn on my own so I can maybe do a career shift or something? Like, is there anything online course, whatever? Like, what's offered?
Yeah.
Julien?
Yeah. So so IBM Quantum offers a learning platform, and we have massive content. You'll probably never go through it all, and that's perfectly fine. But 80% of it is completely free. So essentially, if you're smart, you can become self-taught in quantum. And I want to underline that because the largest quantum user of IBM quantum systems in Canada is a person that learned quantum alone, just using that content that is online. And they are the largest user in Canada. I think it's also the largest in the world, but I'm not 100% sure of that, but one of the largest. So like you can do it if you're smart.
Okay.
I think the good news is that there's, like Julien said, there's IBM Quantum, which is how I first heard about quantum computing. I was studying physics, but even then it was a board day in summer. I came across the IBM Quantum platform, and that's how I discovered quantum computing. But yeah, I feel like there's so much content online. And there's hackathons, there's competitions, and it's all open source. So there's many ways to contribute to the community, and there's Slack channels, and there's a really big community in quantum. So I think it's really easy for anybody who's interested to join. There's tons of different ways.
Maybe I'll add the moderator note on this. There's a lot of content online. You can learn a lot very quickly. There's also a lot of garbage online. So make sure that you get your source from reputable source. IBM, there's a lot of companies that offer. So IBM was probably one of the pioneer in this, but if we look at a Canadian company like Xanadu, Rigetti, so most of either the software or the hardware quantum computing company have some sort of learning platform. Be very, very careful with YouTube. There's a lot of bad or I wouldn't say misinformation, but wrong information. So yeah, but there's a lot of legit stuff. I think there's Coursera, edX also that have online, massive online MOOCs, they're called. Yep.
And if I can add to that, I'm not sure you were going to go into that direction, but
go for it.
Also, don't be shy of saying that you don't have the competency at the moment. Don't bullshit, because people will know. Just say here's what I am. This is where I want to go. And most companies are willing, because we don't have that many, qualified people within the field to say, okay, well, we're giving you, 6 months to get updated. And if you're serious about doing this transition shift, you'll be okay. But don't bullshit.
Right. Yeah. We as a community, I think we've developed a pretty good bullshit detector in the last decade. A lot of people tried, many failed. So I'm going to bring this discussion maybe in a different direction. So it was mentioned before. So quantum computing and actually any other quantum technology, it's very multidisciplinary. So at the technical level, it's a mix of there's engineering, there's math, computer science, physics, all of those fields which are very recognized for their diversity. Sarcasm. So right off the bat, I mean, we're hitting with 4 fields that are doing pretty poorly when it comes to diversity of whether it's gender, ethnicity, even diversity of thought sometimes. So there's really a discussion there. Like open to all. Like, do you see how can the field of quantum maybe help, or are we doing concrete things to encourage diversity, at the workplace and the people coming in, going out, that sort of thing? So, floor is open.
If I can just bridge back to the previous point, I think the fact that there's so much online content makes it a very inclusive space, because there's let's say there's a thing called Girls in Quantum, which is a community of thousands of women who are like under 20 years old, who are interested in quantum computing, and they have this big community and they have mentors and meetings. And so there's so much stuff online. Anybody can join in. And I think on that sense, on the inclusive side, it's great. Then they still need to find a job and to have a safe space to work in. But to the recruiting part and to spreading the word about quantum, I think the community at large, it has very a sense of wanting to be open and to spread the good news. And IBM is huge on that, with Qiskit and YouTube videos about how to find a job in quantum. And so I think on that sense, it's very inclusive, but there's still work to be done in having women in the field. And I think Maria, if you can talk about that.
Yeah, I can continue. I can continue on that. So I would say that you're completely right, and that's the beauty of today, is that you can connect with people that have, you're within their same group, even though there's not sitting next to you. So this community building is very, very important. I would say, and we all heard about this, but representation does matter. So when you're a startup and you're starting, to build your company and recruit people, it's really easy to go and see always the same person you're talking to, because you have this connection. But when you think about your future, you say, okay, well, in a year, I need to have 10 employees. In 2 years, 20 employees, because your investors are pushing you, in that direction. Now it's the right time to think about this, because then when you put photo on your website, it's going to be all white men. And you're basically, you're done. It has been shown that representation does matter, because when you're looking for a job and you go and see at the people's face, you say, oh, well, that person looks like me. I might have a friend at that company, and that's our important things to do. You want to add on, Julien?
Yeah, so we talked about girls in quantum, but there are also women in quantum. So there are already many initiatives that are started actually in the field of quantum. And I think that's great, because they're very proactive as we're just starting to build the workforce. They are already there, already existing, to make sure we promote diversity through multiple angles. So we won't play catch up like in other fields like you named before. So that's a great thing. The other thing is, as I said earlier, you need to be smart, and that's that's wherever your origin, beliefs, gender, doesn't matter. You need to be smart, because that's what we need right now in the field, and we already lack workforce, even if we're just at the beginning. So I think that's the only criteria.
All right. So we're getting close to the end, and I would like to take some time to get some question from the audience. So maybe as a finishing question, maybe we can broaden our horizon a little bit, and let's look down the future, and to make sure that everybody can say something. We don't cover all the subject with the first two. Can you tell us one challenge and one opportunity that we can see moving forward as a community, as an industry? And let's try to think large. Aha.
The one challenge is, so we've all heard about the lack of talent in AI recently, right? When quantum will be ready, you'll think back about these years. We've not seen anything yet in terms of lacking workforce. So these type of events are extremely important. But the opportunity lies really, I believe, in quantum computing. This is an untapped opportunity, yet completely undervalued compared to the hardware. So there is a lot of room for go-getters to actually achieve something big.
I should have been clear. It's one challenge and opportunity per person. So that's good. So Marie-Ève, I'll start with you.
Yeah, so one challenge, okay, I'll go with this one. So as we said, quantum computers, they are there, it's available, you can go online, some of them are accessible to clouds. And a challenge that we do see at the moment is thinking about problems that needs a lot of qubits, because once the technology will be there, we want to use it to its full potential. So I would say that's one challenge. One opportunity is, if you have a great idea, it's still time to start your business. And now, Martin, it's still time, the technological choices are not set in stone at the moment. So yeah, we have those leaders that are huge, mostly American corporations that have made some choices, but there's still opportunities for any type of startup that have this great idea that say, okay, well, I think my idea is good, and if this works, it's going to show. Well, go for it.
Yep. Sarah?
I guess my challenge would be, to have it in the hands of as many people as possible. So not to have very few companies, very few countries who have access to this technology, and it might be not the most ethical or the most fair way to go. But opportunity is, and another challenge would be to find like some useful applications for quantum computing, kind of as Marie-Ève is saying, that are going to be just and which are going to bring the world in a good direction. And the opportunity, so people are saying, oh yeah, quantum is going to solve climate change and, it's going to solve all these problems. But I think it can allow us to take a step back, and that we can't rely on technology to save us. And it's just has to come from individuals. But kind of as a reminder that, yeah, okay, like it's not realistic to just wish upon technology to save us. So I guess that's my opportunity.
All right. Vincent?
I would say is to how can we support quantum technologies from the idea to the commercialized product. This is the challenge. How do we make sure that we can support that? And the opportunity is, if we do have that supply chain, will be so much attractive in Canada for other companies from around the world to come here and get their product developed and supported here.
Well, thank you to the four of you. I think I'm going to borrow a couple of minutes from lunchtime. Feel free to go if you're really hungry. But if you have any question in the audience, please raise your hand. I think there's a mic going around. We'll be more than happy to answer.
I'll bring it over to you. Yeah, we've got about 5-10 minutes for questions.
Yeah, thank you. The question is for everyone. First, when you start in the industry of quantum, there's a lot of players, and it's quite complex to understand who does what and everything. And when I started, I addressed that industry like I did with the internet. And the reflexes, the business practices, are quite different in that industry. There's a culture for the quantum industry, and I'd like to hear you on that. The best example I've had was from the Institut Quantique and others. They wrote the PDF Quantum Potential, Le Potentiel Quantique, which is an amazing introduction to the industry. But if you could comment on the culture that you like to build and what you like to see in the industry would be useful. Thank you.
Yep. So essentially, let's talk a bit about the culture within the quantum community, which is still small, but definitely growing at I think an exponential rate would be a fair statement. So please go ahead and chime in. Nope. Microphone missing.
Yeah. So in terms of culture, I think that we're building a culture that's really forward thinking right now. And we talked about it also, like we try to not repeat the mistakes we've seen in the past. So you'll see a lot of people from the quantum industry trying to tame the hype that can get around it. Quantum is not magic. It's not going to solve every problems in the world. It's going to have very concrete and precise applications where it's going to make a tremendous change, but for only those areas. And we try to, of course, make it as inclusive as we can right from the start. Want to add anything?
Well, I cannot. Now I can give opinions. I don't. That's right. The moderation's done. Maybe I'll take a slightly different tangent. So I've been involved in quantum, I think, for more years than those four combined. So I've been around for a long time. I've been there since 2003 when quantum was. I joined in. It was a cool science. There was cool stuff. I'm a physicist, so I enter, as every physicist, you don't enter physics to get a job, but to do cool science. We knew that there was a potential eventually. I would never have thought that I would be sitting here as a venture capitalist 25 years later, but here we are. So where I'm going with this is the community was very academic, right? It was an academic adventure. It was very, very heavily science-based. And then around the 2010s, 15, that's where little startups started showing up, all right? And then there was some complete garbage startup, and then there was the hype started. And then there was a lot of uncalled for hype, and there was people coming out from nowhere making absolutely stupid claims. Like those people never took the time to read one article about quantum. So the quantum community, I think, is not closed off. I think it looks at the outside with a you're welcome, but don't bullshit me, okay? Because we've been bullshitted before. We've had some people with lots of influence, with zero knowledge, going out that have a huge tribune, and then essentially making us look bad because they're making claims that are just absolutely crazy. Like Ghislain this morning mentioned, manage the expectation, because so much have been put on the back of quantum, like this new magical pill. And a good example was AI, right? In the early days of quantum, where we go back maybe in 2010-ish, there was a very short intellectual shortcut that was like, well, AI lacks computing. Quantum computing offers this unimaginable amount of computing. Of course, it's going to work together. And that went on for a couple of years. Lots of money got wasted. And then we realized, no, that's not true. And then a few years later, we realized actually maybe quantum can help, but we had some theory behind that. And then it started all over again. Now it's a bit more educated, but there's still a lot of hype. So the community is very welcoming. We need a lot of people. Just don't bullshit and don't pretend. We prefer to welcome you as a newbie and embrace you and then bring you in. Then you come in thinking that you know everything, because we don't even know everything, and that's our stuff. So maybe a slightly different tangent on this. Just come in, own up to what you don't know, and you'll be most welcome.
We have time for one more, so I see a hand up. I'll run over there. Here you are, sir.
Thank you very much. Thank you for your presentations. It's a very interesting discussion. I was wondering, in your opinions for the future, are the problems that will be best approached using the qubit structure, will they be those that are that show some high degree of probabilistic determinism, or do you think that qubits will be able to be applied more generally and there won't be that type of structural requirement?
So we talked a little bit about that. Maybe let's revisit it a little bit more in detail. So I guess in a nutshell, what will a quantum computer be good for? Like, what do we know now is going to be good for or not good for? Will everyone have a quantum computer on their laptop? On their lap in a couple of years? Like, let's try to see, like, really, what is a damn quantum computer and who needs it to do what?
Yeah, I can start with that. Thank you for your question. So as you said, Martin, so don't believe everyone will have a quantum computer within their home just because of how we make those and the specificity of the qubits by themselves, or how we control them. However, everyone in the future can have access to it through the clouds. And as Julien said previously, quantum computers will be good for very specific domains of application and very specific problems. So
We want concrete.
Yeah,
Like what problem?
what problem exactly? So for all of the molecular, like drug discovery, what better way to use the nature by itself to stimulate nature? So there's a lot of potential in that field. Development of new quantum materials with, like for example, the superconducting field is also a promising area. All of the optimization problems. So optimization problems gather a lot of data that with a lot of parameters. That's one way. It's not nature. It's not necessarily a quantum problems, but because of the complexity of the problems, quantum computers has the potential to better, solve them. I can perhaps let the hands to my colleagues, or
Just add quickly, like there's many different types of qubits in the field. So there's a company, for example, who's based on neutral atom qubits, and their architecture is specifically good for optimization problems, as Marie-Ève mentioned. So because you can physically place the qubits in specific locations, it can accurately represent a physical map of, let's say you want to place some Starbucks in a city. So in that sense, like there could be a link between qubits, like in their nature, and a link to the problem. But I feel like in general, they're like, as Marie-Ève said, there's going to be many different field applications, but not necessarily in relation to the structure of the qubits themselves. That was kind of your question.
For that type of question, I always like to give sort of two answers. So one of them is there's a lot of things where we know it's going to help. That's been mentioned here. There's a lot of places where we know it's not going to help, but most places we still don't know. So it's still, because quantum computing is a entirely different way of computing. There's still many classes of problem where we don't know if it's going to help or not. So there's a lot of innovation to be had. There's a lot of research. Like there's still a lot of meat on the bone. And the reality is, like, project you back in the 1970s. That was the same thing with the regular computers that was using vacuum tube. We knew what they were good for. We knew what they were not good for, but we would never imagine that right now I'll be talking to a camera who will be going on the net, and then it will be, encoded in a way. We never thought of this or was possible. So, and it's not us that's going to think of this. That will be our kids and our kids' kids, like the generation that grew up with it, that really is going to unleash the power of quantum. But there's one thing that we know for sure that is theoretically proven: quantum computer is more powerful than traditional computing. This is theoretically proven. Now, that doesn't tell you how to build it, and that doesn't tell you what you can do with it. And this is what communities, company, students, that's the opportunity we have in front of us. I had another thing I wanted to say, but I forgot. So
that means
I got too
you're
involved.
hungry. It's time for lunch.
Okay.
A round of applause, everyone. Thank you very much.
Thank you.